Okay, so we have been talking about log functions, and so now it's time to look at some graphs of log functions and how they behave. So the first one we're going to look at is this log base 2 of x. Now log base 2 of x is not something that I can put in my calculator. Now Desmos actually will graph it for me, but my graphing calculator will not. And so if I were going to graph this by hand, this is kind of how I would do it. Okay, so this value here in x, it's always like, it's easiest for us to figure out because this would be asking me 2 to what power gives me this x value. So I start like putting in powers. So for instance, 2 to the 0 power would give me 1, right? So I'm going to plug in x as 1 because that'll give me out the 0, okay? So then I think, okay, well, I'd use 2 to the 0. What if I use 2 squared? So 2 squared is equal to 4. So if I plug in 4 into my x here, that means 2 to what power gives me 4, and that gives me out the 2. So let me do one more in a positive direction. So 2 cubed is 8. So if I plug in 8, I should get out 3. It's right, they're inverses of each other. So I'm kind of thinking, okay, what would it be on here? And then it's the opposite over here. Okay. So then I think, okay, well that's probably enough in the positive direction, right? So let me think, okay, well what happens if I use 2 to the negative 1? Well, 2 to the negative 1 would actually be 1 over 2 to the first, which is a half. So if I plug in a half, I should get out negative 1. And then if I have 2 to the negative 2, that would be 1/4. So that gives me out negative 2. Now you can kind of see what my graph is doing here. I could do one more of these. Let me put in, so 2 to the negative third would be 1/8, and that would be negative 3. So I'm kind of going down here. So that's a general shape, so let me turn on my whole graph then. So this is basically my log base 2 of x graph. Okay. So now that we've seen that one, let me close this table here. I could do the same thing for all the rest, but I'm just going to graph a couple of more. So I have g, which is the log base 4 of x. And so that one, so if you think about it, right, it takes longer essentially to get to the same values, right? So if I plugged in 16, that would give me 2 because 4 squared is 2. So 16 and 2 is clear out here. So the smaller my base here, the taller my graph is going to be in this case. So then log of 10 is even a little smaller there, right? So because it would take 10 to the first is 10, so here would be my 10, 1, and then 10 squared is 100. So that's way, way out here. It takes a long time for that one to get to 2. So all of my log bases to a positive power between greater than 1, they're this general shape, okay? And so what we want to take away from this is if we think of this, right, now remember that logs are inverses of exponential functions. And so if I think of like y equals 2 to the x, that had a domain of all real numbers and a range from 0 to positive infinity, if you remember, okay? So that means that this has like the opposite. So in this case, my domain, and I can see it, right, it goes from 0 to positive infinity, and my range goes from negative infinity to infinity, okay? So they're opposite because they're inverses of each other. All right, so let me also talk about the fact that if you kind of notice all my graphs are plunging here, that is also a vertical asymptote, and we'll talk about how to find that in a little while. Okay, so let's take those graphs off now, and let's look at, so this is, now I couldn't make Desmos do log base a half, so I just put in 0.5. It's the same thing. So now you notice that, again, my domain in this case goes from 0 to positive infinity, and my range goes from up and down, so it goes to negative to positive infinity. Remember, I'm thinking my x's go this way, so that goes from 0 to positive infinity, and my y's go this way. Now, my y is kind of over here. But so this is what happens to my graph if my base is a fraction. So between 0 and 1, it's basically just flipped. So I still have a vertical asymptote here at x equals 0, but this time my graph is going in the opposite direction. So it's kind of like, you know, if you graph 1/2 to the x and 2 to the x, those graphs increase in different directions. And so this is the same thing with logs. All right, so then this is log base of a fourth, right? So it's got the same general shape. And you might notice that they all, I didn't point it out to the last one, but let me put these all up here for a second. These actually all have the same intersection point, right? Here at 1, 0, because any number to the 0 power gives me 1. That's why this point is, they have them all in common. Okay. Now I talked about the horizontal or the vertical asymptote. Now we have no denominator to set equal to 0. So instead, this time what we do is we just set this thing inside of here equal to 0. So we've already discussed that 2 to a power can't be 0 because there's no positive power, or so I have a positive base like 2, and I'm trying to raise it to some power that gives me 0. It's not possible, because if I plug in 2 to the 0, I get out 1, and 2 to negative powers give me like a half and a fourth and an eighth, and I can keep going with a 16th if it's to the negative 4. So there's no number that I can plug in as my exponent that I'm raising a positive base to give me 0. So the fact that when it is 0, I get this vertical asymptote. So essentially whatever is in here, right, these are all just x, that's my vertical asymptote. And my domain is just this, what's in the parentheses is greater than 0. So let me change this a little bit. So I'm going to shift this 1 to the right by putting a -1 here. This acts like just like all of the other graphs that we've looked at. So let me take these other ones off. So now my shift, my 1, 0 to the right has become 2, 0. So it's 1 shift to the right. So now this one, if I set this equal to 0, I get a vertical asymptote at x equals 1. You can see it, right? Let me scroll down here a little bit. You can see that it's plunging, and it looks like it's right up against the line x equals 1, but it never really quite gets there. And then my domain for this, you can also see, is strictly greater than 1. At x equals 1, I get a vertical asymptote, so everything bigger than 1. So I just literally, just like, square root, if I had the square root of x minus 1, I pluck it out, but except for the square root, I would say it's greater than or equal to 1. With the log, it's strictly greater than 1, because then x equals 1 is a vertical asymptote. Okay. So that's kind of an idea of where we're going. All right, and I wanted to just quickly talk about, I just wanted to show you these inverses of each other. Oh wait, let's see, what do I have down here? Let me take this one off. So I have 1/2 to the x, and the inverse of that was this log base a half of x, okay? And I'm going to put this y equals x on. So I just kind of wanted to show you once again, right? So if I kind of turn my head and I look at this y equals x line, right? Oops, sorry. I turn my head and move the camera at the same time. So if I turn my head and look at y equals x, then I can kind of see the symmetry, right? It looks like there's a reflection over the y equals x line. They look very similar, okay? So basically this black line becomes this green line here, and here this one becomes basically this one. So there is symmetry with this y equals x line. And the same goes if I change this to 2 instead of a half to the x. Let me change this to 2 to the x. And instead, actually let me just put 10 on, because that's a nice easy one to do. So let me take this one off. And then this log here with no base is considered base 10. And so now this one goes back to the first type of log that we looked at, where it looks in this shape, and then this one looks like this. So again, this one kind of looks, if you turn your head to the side, kind of like a butterfly shape, right? It kind of looks like where this is sort of like, even though this isn't really there, this line y equals x is sort of like the body of the butterfly. All right, so that is what my log graphs look like. Now I wanted to talk briefly about what these do when I shift them. Now for some reason I had to make a completely different graph here, so let me come up here and show you this graph. Okay, so this is, I've got it like in a form where I can do transformations with it. Now these all behave just like all of the other graphs, it's just I have a different shape. I didn't put my projector mode on there. There, that's a little bit better. Okay, So the first thing that I want to do here is, let's see if I can widen this a little bit. So if I change A is out in front, and before, right, and this happens again, when A is bigger than 1, then I got a vertical stretch. And I'm going to have the same thing here. So I just have this going from basically 1 to 7. So you notice it's just pulling my graph up. So when A is positive, that's the number sitting out here in front, and it's a number bigger than 1, then I get this stretching. It's stretched by a factor of whatever A is. Okay? Now if A, let me stop this, if A is going from 0 to 1, then, let's see, let me change this to 0.25. Then I get a different scenario. This one, it's going to be because A is less than 1, it's going to be a compression. Okay? So this time, you notice it's like pressing it down. Oh, that got flat for a second because it doesn't exist there at 0. But essentially, when I'm going from 1 to 0, it's pressing down. So the smaller my A value, it's basically compressing my graph onto the x-axis. Okay? So this acts exactly the same way. Like if I put a 3 in front of x squared, that's considered a vertical stretch, versus 1/3 x squared, that's considered a vertical compression. This A works exactly the same way. So let's go, we'll leave it at A as 1 because that doesn't change things. So H is in here with the x. Now when we put it, when we were transforming graphs like y equals x squared and we put in x minus 3, then that moved our graph 1 to the right. And this does the same thing. When H is positive, it moves me to the right, and when H is negative, it moves me to the left. Let me zoom this out a little bit because it's going to move in both directions. Okay, so there it's positive. Here it's negative. It's just shifting me back and forth. My H does exactly what it did in all of the other graphs. Okay? Alright, so let me come back here. Let me make my H 0 again because I don't want it to shift. Alright, so let me look at my K value. So my K value is outside, and just like the K value before, it shifts it up and down. Okay? Alright, so let me talk about one more quick thing. Let me shift this back to 0 again. Let me look at my normal function again. Now if I want this to reflect over the x-axis, then my negative sign goes here. That's right. It just flipped it upside down. Essentially, all of it, the graph just flips over, and I kind of have this lever here at 1, 0, and it literally just rotates across it. Oops, I got 2 negatives there. Okay. So, and if I put a negative there, that's what it happens. Now, if I want to reflect it over the y-axis, then that means I'm going to put my negative on the inside here with the minus x. Right? So that would mean, like if I take away, let me take away this h here for a second. So if I have this, my graph looks like this. And this is legal because my domain would be, I'd pluck out the negative x and say it's strictly greater than 0. And then when I divide by -1, I have to say that x is less than 0 is my domain. Again, I would have a vertical asymptote at x equals 0 because that's where negative x equals 0. Alright, so if you have any questions about these, just put them in just like this into Desmos and play with them. Alright, but they behave, it's just a different shape, they behave just like all of the other graphs that we've done.